and thank you all for joining our 83rd edition of Geek Night. So, thank you for your participation. So, before we get started, right? So, if you have any questions, please feel free to raise your hand, or you can even put your questions on the QA box so that we can answer it right away. Cool. I think we can get started with it. So, for the first half of the session, right? So, we are going to have a talk about blockchain platform DApp, and Devashish is going to discuss about various related terms and with a viable use case demonstration. So let me brief about Devashish, so who has an working experience with ThoughtWorks as a consultant with various fields on blockchain, search engine, data science, data engineering, and data analysis, and also has an experience with marketing, DevOps, full stack, and also support. So he has been in crypto and blockchain ecosystem for 7 years now. So we're very pleased to welcome you, Devashish. Over to you.
Thank you so much, Monica, for that amazing introduction.
Yeah, thank
Yes,
you.
thank you. So yes, I have been working on crypto for a very long time. Since college, I guess my final year project was around based around network security. It is around crypto and how to access control various things. So I have been interested in blockchain, Bitcoin. I've been following the updates on that, right? And they have been it is doing quite great in this time, I can say. So yes, I have experience of working on blockchain. I also have worked as a software consultant with ThoughtWorks and on various data platforms. So I'm going to demo one of the projects that we did for blockchain a while back, right? And hope it will be useful to you guys, right? And to understand the core meaning behind what we are trying to accomplish here. So let's get started right away. Uh, yes, I hope everybody is able to hear me clearly. Shall I share my screen?
Sure, go ahead.
Yes, sir.
So, okay. So uh, this is my session on blockchain platform distributed applications. So if you're so basically when you're starting on a blockchain project, right, it is very common in a lot of places outside of India, like in Europe, and but I think awareness in India is a bit less comparatively. So the ecosystem is still emerging for a very big chunk of the people, and I think the first question we should ask is what is a blockchain? So in blockchain, right? So the meaning of the word blockchain is you're taking some fundamental blocks and you're turning them into some concepts or some contracts that we can use, and you're making a chain or some sort of uh, you're making some sort of ledger where you are recording the things that are happening. So it doesn't necessarily have to be a linear thing, the chain. It can be a network, it can be a integrated system of data, right? So a lot of people have said that blockchain is one of the biggest discoveries of, like, not just of this century, of the millennium, because it is solving a very big problem that we are having right now. So this problem is known as consensus, right? So the problem that consensus happens to have, for example, I can say that Bitcoin is a proof that we can solve consensus issues among people. So it is solving the consensus of money. That is one of the blockchains. Blockchain is one of the core concepts in Bitcoin as well, and it is applicable to a lot of other fields where it is being used by people who are uh, who are using it on the back end with their clients. And a lot of times people are not even aware that they are on a blockchain or their data is on a blockchain somewhere. And so let me define what the consensus problem is. So first of all, when you're talking to a client, right, about what is blockchain, or when you're trying to start a blockchain project, you need to understand who are you trying to create consensus among. So so there are multiple people who would be talking to each other, right? So you can either be creating consensus between clients and their other clients, or you could be doing it between the clients and their customers, or you could be trying to share some information between both clients and customers. In other words, it's like B2B or B2C or both, right? Business to business or business to customer. It could be any of these things. And these groups of people, right? I think we are very clear on how a single person should be acting in any given situation. but still right now there is a lot of debate that goes on what groups of people should be doing. So for example, a company is a group of people who is working for a particular purpose, right? And customers are also of different types. So what is the consensus that we are trying to create here? So let me give an example to explain this much more clearly. If we take money as an example of consensus, so the consensus in money is about revolving around questions like who deserves how much money for how much effort, right? First of all. Secondly, if a person is not working for the money, let's say someone is investing the money and they're having some vision or they're creating something, how would they get rewarded in the future? So money is an abstraction here, right? It is representing the hard work that we as people are doing to society. And it is in one sense it is priceless, right? To have a railway system or to have some service that is provided like Uber, to have that sort of a thing in India, it is like priceless, because if such services did not exist right now, we would be having a lot of issues with respect to our productivity. And for some people, it is necessity also. So when we are trying to establish consensus here, right, we need to have some basic fundamental blocks that we agree on. Some fundamental concepts are there that we should be agreeing on, and these should be very clearly defined. And the rules should be very specific, because when we get into some sort of a platform, right, so the first thing, I think we need to understand some of the core concepts that are here. So I'll just give a brief overview before we begin. There are two other presentations that I have given in the past. We can discuss those briefly, and when we are done, right, we can look at the code also. So we will be going over this. So I'll set a timeline, and we have a live example also which is working. So we will be by the end of this session, we will be I will be covering all these things, and then we will be taking some questions and answers sessions. Okay. So this is the general structure of this talk. So back to my presentation. So the core concepts in blockchain, right? So the first thing you have to understand is there is something known as a platform. So a platform is something which is ubiquitous. An ubiquitous platform is something that people use without even knowing that they're using it. And an example of such a platform is AWS. So for example, if a person is booking a bus ticket from Redbus or some Abhi bus or some app is there, and they're booking a ticket, so now they are paying the vendor some amount of money for their bus ticket, and they may or may not be aware that Redbus is using something known as Amazon Web Services in the background. They are paying their hosting their servers there, right? So for every 1,000 rupees a person is giving, maybe 10 or 50 rupees is going to AWS, without the person even realizing that they're paying for such a thing, right? So this is what platforms do. Platforms enable companies and businesses to build on top of something, and it is ubiquitous in nature. So it is something that anybody can take advantage of at a particular point of time. So this is the concept of platform. So blockchains are these platforms where you are trying to have some consensus about different things. So a lot of blockchains are existing that are there, and a lot of them have yet to be explored. So it's a blue ocean out there where a lot of blockchain projects will be starting in the next 20 to 50 years, right? Lots and lots of projects will be starting, and these will be creating consensus on a lot of things, right? So I think Bitcoin is a very good example to study what is going to happen in the future, in the 21st century, and in the coming millennium, about how we are going to store our data and how we are going to play with it, right? So yes, how it is going to be useful to society in some sense. So this is one of the concepts that is important. So so the most important thing for a platform, right, is for the concept to be very effective. So the concept whatever you are trying to do in the blockchain, it has to be very effective. It should not be just for looks or for show, right? So uh, so what is being effective in one sense? So being effective in one sense, right, it depends on what your client wants. There is a special branch of maths known as measure theory, in which people will be measuring. There are different concepts on how you can measure something. For example, if you take a human and you put them in a pond, and you compare them, the humans measure by their ability to swim, and you put a shark also in the water and you compare them to swim, right? The human will not be able to swim as fast as a shark, right? Or a dolphin. That doesn't mean that a human is bad. It just means that they are not very effective at that particular way of measuring things. So we have to be very careful about what this measurement is, that what are these expectations that clients or people have from us, right? And that is what it means to be effective. So I believe that everybody is effective in their own way. If you have a team of 100 people, they will be effective in some way or the other, right? But there is a metric that is there at play, and you should be able to understand that metric very well. So in blockchain, some of the core concepts that are there that lead to effectiveness, I can say these are events. First of all is data event, and the second thing is known as the legal, the concept of contracts, right? That is the second concept. And the third concept is distributed nature. So what is distributed nature? And that relates to auditing, integrity, and so on, right? So yes, I hope I'm audible to everyone.
Yeah, we are able to hear you.
We
Yes,
have one question from Lennon. He has asked,
please go ahead.
miners can create a block or networks only can create a block?
Who can create a block?
Miners can create a block or networks only can create a block?
Correct. So let's think about this abstraction. So I talked about some legal contracts that are there, right? One of these legal contracts are known as miners and networks, right? So you can have these contracts of what constitutes a participant of the network, what constitutes a part of the company, of different companies, and you can set their access levels, and you can create a different role known as a miner, and you can set their access levels. So when you are asking a question of like who is going to set uh, the block, right? Who is going to create the block? In blockchains like Bitcoin or some cryptocurrency, the miners are setting the blocks. They are creating the blocks. But creating a blockchain, you as the architect have the control of how you want to design the architecture of the blockchain. So we will be discussing in this thing some of the fundamental things which will help you to understand what exactly is going on. And once you have understood, like once I'm covering those things, we can talk specifically what miners are. So in let me answer that question in the Bitcoin sense. So in Bitcoin, yes, miners are the ones who are creating the blocks, but they are not creating the blocks for themselves. There is something known as a person, and they can create their own bank accounts. And the problem that is being solved there is that a person is not having their own bank account, or if a person is starting a business or a company, they need a way of accepting and receiving payments and giving payments to people. So the traditional way of doing it is to have a bank account, but then bank account are subject to laws of the area, the country they are in, and also they are having these each bank has its own rules, and they are having some common rules between these banks which allow money to be transferred between banks. Now the problem that Bitcoin is solving in today's day and age is that it has become a universal currency. So it has become a universal currency where you can transfer money to anyone or anywhere on the planet, and it represents your hard work, and you are able to get products and services from them, right? And this is why Bitcoin has been increasing in price also recently. It has now recently there is a surge of companies acquiring Bitcoin and using Bitcoin to accept and receive payments in their for their customers, which is why the price has been continuously going up, because the demand is increasing, and these all things are there. So coming back to the question, yes, the miners are determining in this case what the consensus is. So the consensus is determined by the miners because they have been given that privilege in Bitcoin. They have been given that privilege because they are the ones who are maintaining the distributed nature of the system, right? And the system is being maintained by them, which they are getting a small transaction processing fee, and that is why they are working, right? So these are some. This is the. But no, not necessarily. The miners have to be the ones setting the consensus. there are other things like Ethereum. So in Ethereum, if you are aware of the platform that is there, there will be a lot of uh, other things where people have permissions. For example, Microsoft as a company has a permission on who can do what, and they are able to create contracts where they are able to veto the decisions that are taken, or they are able to announce to the world that this is exactly what is going to be happening, and this is fixed, and this is what the remaining people can work with on top of that. So not necessarily is the answer to that question. Does that answer your question, Lenin?
I think you can continue. He said thank you on the message.
Okay.
Yeah.
Yes. So, okay, continuing with the concepts. So, there is a concept known as event, which is very important to any blockchain. So, you can think of any sort of a data collection system as a pond where it is raining events. So, there is a continuous stream of events which is coming. It is raining events uh, time to time, and all of these drops are they are collecting in the data lake, so to say, right, or a pond. And this is basically an event queue where this is an abstraction known as an event queue where events are coming in, and then you are selecting some mechanism to process the events. For example, you can set it as I want to process events every 10 seconds, or every 1 second, or every 1/10 of a second. In Bitcoin, it happens to be every 10 minutes, right? So this is the concept of event queue. Now, why does an event queue exist in the first place? In from the point of effectiveness, I would say events are very effective because you can receive events asynchronously, you can process them asynchronously. Why would you bundle them up? Why would you have an event queue in the way and then pull events from the event queue? I think it is because we want to tackle the problem of concurrency or consistency or double spending. Some consistency issues will arise if events are happening at the nanosecond level, right? If they're happening in a few microseconds or a milliseconds, and the latency between a network, a distributed network, is larger than that, then it leads to consistency issues. So this is the reason that something known as an event queue exists, right? And when you're designing a blockchain, you would want to have an event queue where people with different access permissions will be able to post events to the queue. And then you need to have a system where you are providing some sort of consensus on how the events are getting processed. So from a metaphor point of view, if you're thinking of the events coming in as rain in a pond, then the events are getting processed, right? So they are getting processed and you're like emptying the pond, you're draining all the water, and then the new events are coming and they're landing. And while you're draining the water, new events can be coming at the same time. You can set a level that, okay, I'll drain this much of water, right? And that is basically what you're doing when you're processing these events, and then you're making a link out of it. So let us talk about distributed systems now. So this is the second concept, right? So we will be recapping all these concepts later. So what is a distributed, why does a distributed system exist? What is wrong with having a single server that is processing everything? Well, first of all, a single server has a limit on resources. For example, how much CPU and GPU memory it has. Those are some of the constraints of having a single system. But a distributed system is very important in case of failure. So in case something is failing, you need to have some resilience in the system, which is why a distributed system exists, right? So from a point of view of resilience and gathering more resources and giving people the power to choose, these are some of the things that come from having a distributed system. And there's one more benefit of having a distributed system, which is basically you are able to sync things to offline. So now from a client perspective, anything that is happening, they will be verifying it at any given point of time. So they might be having their own Excel sheets or databases where every month or so they will be getting these data dumps, and they're either verifying it by people, different teams of people independently who are verifying these, or in some cases, these are paper trails. So they will be printing them out on paper and they will be keeping them there just in case they have to go back in time and check what exactly happened. So the order in which these events happened and how they happened are very important. And this is also why a distributed system is good, because it allows someone to sync things and keep it offline, and then make a backup of it and then resync it. And so when we are using these distributed systems, right, there is something known as a legal contract. So a contract basically specifies what in which way the event will be processed, and this contract has to be defined well in advance. So before the events are coming in the first place, right? Now the events are coming in every 10 seconds. You're creating blocks and you're chaining them together. Now before the events are coming itself, the contract needs to be very non-ambiguous and not open to interpretation in any way, right? And these contracts need to be created in some place, and this forms a sort of rule book that is core to any blockchain. That these are the set of rules or contracts that we are using. And also these are known as smart contracts, which have a lot of uses in AI. It has a lot of uses in legal. It has a lot of uses in a lot of places, and you can roll out these things. So just like we roll out database updates, right? We roll out a database update, a change to a table. Similarly, we can also roll out these contracts where we can say that this contract has been rolled out, and uh, after this point of time, you can set a date 10 days in the future or 1 month in the future. The old contract will become redundant and the new contract will become active. So this is how the way that events get processed will change over time. So yes, so even if changes are made in the system, right, there is a log of how these changes are being made. And this is very important from a client's perspective, because if the rules have changed now and they want to look at what happened in 2018 or 2017 or 2012, right, they need to understand what rules were there in place at that time. What were the contracts that were being executed? So having a understanding of this is very useful in any blockchain.
Sir, I have one doubt, sir.
Yes, please ask. Yes, Lenin.
Can I ask?
Yes, yes, Lenin. Can you hear me?
Yeah,
So,
Lenin, you
so,
can.
so the puzzle is solved by determining a nonce that generate a hash value, and the result and output is lesser than a given target. So, can you explain what is here lesser than a given target?
Okay.
He what mentioned in the lesson target, lesson than output.
Okay.
Can you
So
explain with a real time example, please?
yes, so I will explain. This question is regarding the cryptography part of blockchain.
Yeah,
Until
yes,
now,
sir.
I have been talking about the concept of blockchain and how it is useful from a client's perspective. So if we
Okay.
talk about from a crypto point of view, I can say that there's something known as a nonce.
Nonce. Yeah, yes, sir.
Yes. So okay, what I will say. Yes, let me just move my zoom thing there. Okay, now I can see clearly. Okay. See, so when I talk about, this is a sample blockchain that I've created, right?
Okay,
So
okay,
now I
sir.
have, yes. Mhm. So there are some public key. I have created some roles, like there's a miner who has some access levels. There are some people who are basic customers, and then you can have 2 or 3 companies who are creating their contracts.
Okay.
So the first thing that will happen from a crypto sense is you will be using some algorithm like RSA or ECDSA, elliptical cryptography or RSA, and you'll be creating a public-private key pair, right? So this public-private key pair will be created. Uh, I can say it in some sense. Okay, this is my GitHub profile. On this,
Okay.
it's on github.com/devssh, right? And there are some things that are there. For example, there's a project called SCASEO and a blockchain full node, which is a Java, which is the project that I was showing you. And there's a prototype chain, right? So now if you are having something known as a user, so let's say there is a owner known as Rajiv, right?
Okay.
And they are having some message and Aadhaar number.
Other number. Okay.
some data can be there, any metadata is there. So, you will create a public-private key pair, right? And then you will be able to sign signatures. So in one sense, I
Sir,
can
sorry,
say,
sir, your voice is break.
my
Can
voice
you
is,
come again, please?
Lennon, I think your network is having some problem because we can able to hear him very clearly.
Ma'am, sorry, ma'am, I can't understand.
I think there is some issue with your network because we can able to hear him very clearly. So,
Okay, ma'am. Can I disconnect and after I join again?
okay.
yeah.
Hello.
Yes, yes.
Yeah,
Then
sure.
hey,
Deshish, please go ahead. You can
okay,
continue.
sure. So crypto part of it aside, right? We can come back, circle back to that later. And I think I should be checking the time also. Another 30 minutes are there. So 15 minutes to this. Okay, I'll just move quickly. So why would clients use blockchain, right? So basically, yes, let's just recap quickly. So blockchain is about consensus. We discussed the concept of platform, what is measurability, and what are events, and what are the distributed apps and legal contracts. So basically, clients love events. They love resilience. They like contracts. They like to have consensus between their shareholders, the customers that they are providing services to, and what the terms of the service are, right? For example, any work contract has a statement of purpose, SOP. So, you can have these legal things in the blockchain. And they also like to be able to audit things. And the target demographics are there. And what is the relatability of something? How easy is it to relate to it? And, so many things are there. So, okay. So let's move on to the crypto part of this presentation. So, okay, let's say there's a blockchain. Now in this blockchain, there are some users. Now, users can create themselves, they can create their public and private key pairs. So the public key is like their username and the private key is like their password. And, they will never share their password with anyone. They can keep it offline with themselves and they can make their public key public without actually revealing who they are. Or they could also choose to reveal who they are. Right? Depends on how you are designing the blockchain. Now, once you're having the public keys, right, you can create some message. So for example, let's say I want to create some token, right? And I want to create some token. And what this token basically looks like is, let's say I want to create some coupon, right? So if you see the type, a company can create a coupon and a customer can redeem it, right? Somebody called ABCD can redeem it, right? So what will happen is, there is a they have now this company, it has created a legal contract which is known as a coupon, and it has created the contract such that this is the coupon name and we will be sharing this coupon name with our customers, and the first 1,000 people to use it will get a discount of 20%, right? Now, how would they go about adding this data to the blockchain? So what they would do is, they would have a public key and that public key will be known to all the customers. So now there are a lot of anonymous people, or they can be pseudonymous, they can be known people. Now they know that this is a company, the public key is there, right? And then there will be some data known as coupon. It will say that this is the coupon. First 1,000 users, it will be having that data, first 1,000 users can use, and then they will be creating a signature with their private key, which is basically a hash value. Now this hash value is completely random. This signature, block signature that is there, it is a completely random value. So in this case, it is a hexadecimal number. So it can go from 0 to F. Now, when they are creating this signature, right, what they will do is they will make it a bit hard. So if I'm creating this signature at random, the first digit, it doesn't have to be 0. It can be any number, right? It could have been 1 or 2 or 3 or 16. But I can create infinite number of signatures. So what I will do is, I will start hashing signatures and I will find the first signature which has a 0 on it. So approximately if I create 16 signatures, I'm expecting to get at least one signature which will have a 0 in it. Now this is not necessarily exactly 16. It could happen on the 9th try, or it could happen on the 20th try, right? But approximately around 16, very close to 16, some confidence interval is there in which the signature will be created. And you can set some difficulty. So in this block, the difficulty is 3 zeros right now. So the difficulty is 3 zeros means to create a signature, it takes approximately 4,000 tries, right? And or nonces. These tries are known as nonces basically. So you are adding some data, and that metadata is changing the signature. So you're adding a data of 1, and you try to hash the signature. A value comes, you change the 1 to 1,000 or 2. You keep changing this number until you get a beautiful looking signature which starts with 3 zeros, right? So this is some difficulty that you have added, because the difficulty is added in the sense that these links, right, they are like, think of your system as a ship in the middle of an ocean, and now you're having an anchor, and that anchor has been put in the ocean, and the links are falling down in the water, and you're creating these links and you're putting them in the water, and as they keep getting submerged, right, the more the link gets submerged down, the harder it is to change it in the future, right? So you are creating these links and you're submerging it in water, and this distributed system represents a lot of ships in the ocean who are again copying the first ship, who are basically copying the majority of ships. They are copying, once again, it depends on what you define as majority, right? Totally up to you what your definition should be, or if it should be majority at all. Maybe it can be someone with the authority to do it, right? And these ships they are syncing with each other, so they are copying the first ship, and they are also dropping their anchor, and they're syncing the links one by one. So the older a link is, the first link is known as the genesis block, and this block is having this is the anchor point. So anybody who knows the genesis block can start syncing with the system, right? And then you will be creating these links, and the transactions will be happening, they will be getting signed up, so you can verify the things, right? So I can verify, it will say that it's true, this signature, this data, and this public key, it will be verified. If I change the public key, if I make it some wrong key, it will say it's not true. That is basically a signature, right? So this is basically how a blockchain looks like. And if you're looking at the blockchain, right, so this is a basic block. It has now this is a block, this thing that is shaded right now. This is a block. This is a link in the system. So what it's saying is this data, it could have had a lot of events here. Now at this time, only one event happened. But if 1,000 events were to have happened, or 1,000,000 events were to have happened, they would have all been processed at the same time. And the transaction will be having some ID, it can be having some metadata, and the public key is there, and the password is not there. The password is not there, the signature is there. So the signature has been created for everyone to verify that, yes, I have created it. This is a part of cryptography where you can, create a signature without revealing your password. That is, something which cryptography allows us to do these days, right? And yes, so you're having some time. So the block creation time, and this is the nonce. So the nonces are there. Now you can see we went here extra hard. Instead of 3 zeros, we went for 4 zeros, and the nonce went out to a much higher difficulty than it would normally go, right? So this is what a blockchain looks like. It's a bunch of blocks. They all have their signature. We can also go to something like blockchain.com. So blockchain.com, if you're going to the Explorer, this is also an example. So see, you will be seeing some hash rate is there, which determines the difficulty. The transactions that are happening, the volumes that are going, this is a contract. In this, the contract is defined by a Bitcoin, right? Bitcoin is the contract. And there are blocks that are mined. Each block will be starting with a couple of zeros. This is the difficulty. Currently it's 9 or 12 or 18, right? It will be showing the number of confirmations. As in that, when more confirmations are happening, the link is sinking deeper and deeper into the ocean. And this is the height of the link from the ocean, from the anchor point, right? And the miners are there, and transactions, that the data points that are kept inside. So Bitcoin, it has been dealing with the issue of RAM, and so many things are there. So typically a block will be exactly 1 MB in size. So they have already calculated by the time it is 1 year will pass, the blockchain will become 1 GB bigger, or 5 or 10 GB bigger. So since it has started from 2008, the current blockchain size is around 200, 300 GB. And by the time 2030 or 2040 comes, it would still be under a terabyte of data. So this is a confirmed thing. So everybody who has a terabyte of space on their laptop or hard disk will be able to download the entire blockchain of Bitcoin, right? And this is the Genesis block, which is known as the Merkle tree. And there are some bits, some weights. So this is the nonce, right? And so many things are there. These are all relating to the contracts that are there. This is the data. The 3000 transactions are there in the 10 pages that are there. These are the public keys that you can verify individually. So you can check your money is there, and only you can, others can also check it, but only you will know it's your money, because you are giving the signature, you're not giving your password. This is an example. So let us look at some of the code parts of it, in which you will be able to understand things much better. So basically you're having some public and private key, right? And you want to encrypt something, you can generate infinite number of public private key pairs. You can encrypt and decrypt stuff, and you can also sign it, right? And this is okay. You can read the paper. It's there in something known as IND India Journal, IND-JST, right? You can read this to understand the crypto part of it. And there's a blockchain full node where we will be describing how the contracts are there. So if you want an example of how a sample blockchain you can create and what are all the things that are there, so you can see what is the controller looking like. This is there in Java. It's a Spring Boot app. You can see how to create a contract, how to create a transaction, how to complete a transaction. So some of the abstractions that you would see in a typical blockchain. Let me just go over some of the things. There would be addresses, coupons, keys, how to create different keys, public key, private key. How would you be signing it? What is the algorithm you're using to sign it? Algorithm can be ECDSA, it can be X509 encoded key spec, which is a very specific type of key space, right? And this time is really not enough to discuss all these things. So I'll just move quickly, but we can catch up sometime other in private. We can talk about these things, right? And yes, there are so many things. I'll open IntelliJ in a minute. So this is something known as a prototype private keychain. This is the project that I'm currently running. I'm running it using Docker. So if you just download this app from GitHub and you're running Docker Compose up, not this one. If you're just doing Docker Compose up, it will create the image. It will create this. You can go on localhost 8080. And you can see some things. So I've created these are the controllers. So there's a blockchain homepage, signature controller. And you can see what defines a block, what is the block, what is a block class, what is a hash, what is the variable, how do you authenticate people, sample example, how do you manage keys, and public and private keys, how do you manage. We were having some QR code services at that time, where we are using a QR code or a bar reader from a phone, or a person can just walk up to a phone. They can walk up with their phone to a point of sale terminal, and it was a completely autonomous terminal where no cashier is there at the sale point, right? In Krieger and NAM, and they can just use their phone. They can scan it, right, the QR code, and it will be having the information, and their offline app will be creating their keys, and depending on their keys, the signature will go to the service. It will get distributed, and we can change the contracts. All of these things were there, right? So let's see, we can get the entire blockchain. You can get a particular block. If you have the signature, just view it. You can get it by transaction ID. It's like a map of a sort, right? Blockchain is like a map. You can go and find it. Actually, it's a very big map. Map means, the signature has to be unique. It doesn't have to be unique. It can be a multi-map. So many things are there. It just depends on your imagination. how you're visualizing your entire blockchain thing, right? And what you're taking as reference. And in a few minutes, I'll be showing you what are all the references. And then we'll be starting the Q&A session, where I'll just talk with people directly in case they have any questions, right? Especially Lennon, who has been very nice here, right? So you can see you can sign things with private key, you can encrypt some data, and you can sign it by someone, and any person anonymously can verify any person who doesn't even have the private key. So if you look at the parameters, you don't need the private key to verify. You need the private key to sign, but you don't need the private key to verify. You just need the message, and the person who is claiming that the message is his, right? In this case, it could be a company, it could be someone anonymously, a customer, or a client of the company. So many things, right? All depends on your imagination, once again. And yes, so you can see what are the libraries that we can use. If you are checking out some of my earlier projects, you can see how to do it yourself also. You don't have to use any library. You can create it yourself. I will be sharing the frameworks also. So nowadays, AWS has its own blockchain service that you can be using to create blockchains. Otherwise, Ethereum is always there. There's something known as light wallet, right? Or partial wallet. So you can be taking that as reference. And yes. Okay. So just coming back to my presentation here. So, you can check out zero knowledge proofs in your free time and what is blind signature, right? And I'll be letting you know what are all the different things. Blockchain is also very useful in government if you're having government contracts, right? It is also very useful in terms of government and voting and all that sort of stuff. And we are currently in blockchain 3.0, which is where blockchain is becoming useful for businesses where HIPAA compliance is there, medical records are there, or government operations are there. How governments are trading bonds between countries and so many things, right? So basically, you have to achieve consensus. You can have a mining, you can have, let me just cover this quickly. Sure. So I'll just tell you what, right? These slides that are there, right? We can be having these slides, these two slides. I will be sharing it with you, and you can subscribe at this place, bit.ly.com/blockchain-geek. I'll be sharing these slides with you, or I'll make it on public on GitHub somehow, and you can be going over this material. You can check it at your own free time. For those of you who are very interested in this, right? Let me know. We can form a group. We can talk at some other time. And some of the frameworks that we have used in the past in ThoughtWorks are Quorum, Solidity, Truffle, is something known as a Hyperledger, right? Which is having their own fabrics. These contracts are known as fabrics and hyperledgers. And the use cases are so many use cases here. I have slides and slides on what these things are for when we propose to a client, and we got that proposal successfully done also. We got a project that has started in blockchain, right? It was you can pick anything. The client can be needing any of these things, right? This is like a very small list. I had a slide which had like 40 or 50 industries which could be using blockchain. And yes. So, these are the things. So let's talk about just questions now. And yes, just I'll keep this slide here. Thank you so much for listening. Let's have some Q&A session and we'll wrap this up. This is the link. And if you want to take a screenshot of the recap to remember what all happened, you can. I'll just pause here for a second. Or something about the code, anything you can ask me.
Thank you, Devashish. I think we have few questions on the QA box.
Yes.
Yeah. So the first question is from Lennon. So he's asking about, can you explain what is PK script? Public key. Can you explain what is public key script?
Public key script. Yes. So public key, private key, right? It is basically you are creating a public key, which is, so your public key, you can make it public and your private key will be private. This is something known as asymmetric encryption. the term originates from something known as asymmetric encryption, as opposed to symmetric encryption. So symmetric encryption comes from HTTPS protocol. It also comes from DES, but asymmetric encryption comes from RSA. So if you are checking out the RSA algorithm, in particular, just Google about RSA or ECDSA, what is elliptic curve, DSA, right? And yes, you can check out these things, or X.509 protocol, and you'll be understanding what is a public key script is, PK script. So you can create infinite number of public keys and private keys, and the public keys have to be made public with the data or the transaction that you're publishing, and they have to be made public with a signature. And you will need to have a service which is managing your public key, it is managing your private key, it is not exposing your public key, and it is exposing the signature. The function is returning the signature. And these things can be done offline. So there is the concept of hot wallet and cold wallet. So cold wallet basically means you can offline, or when you're not connected to the internet, you can use your public key to create a signature, and then you can transmit only that data to your hot device which is connected to the internet, right? This can be done by any number of means. You can disconnect your network and reconnect it, or you can use a USB drive. Yes, right, you can do this in many ways. And this is how you'll be transmitting your public key and your signature, so that anybody can verify that the data that has been given by you only, not by someone who is pretending to give that information.
Okay. We have another question from Aftab. He's asking, can you explain again what is a contract?
Okay. So when I talked about events, right, your blockchain is having some events which are coming in, and they are getting pooled up in the event queue. There's something known as pooling or pooling. So there's a pool. That pool is gathering water, and you have to keep emptying this pool. Otherwise, the water will exceed. It will get overflow, right? So you have to keep extracting this water from the pool. The events need to be processed, and to process this event, you need to have something known as a contract. Now, this contract is a function which takes in some list of events, a list or a map or a network of events. And these events are interrelated, they can be individual, and it defines the rules for in advance for how to process these events. And these events that are happening, right, they have to be belonging to some category. So they belong to category 1, 2, 3, 1000. And these categories have to be predefined by you. And in what category, what is the protocol to be followed, has to be defined in that contract. And if the contract is having an edge case which is undefined, you should be mentioning that also, that this is undefined. So in that case, that event will be discarded, or it will be, you can have a separate queue of events which have gone corrupt, and you can then form a new contract to resolve those things, those issues. So this is a contract. Now, a smart contract, on the other hand, is something which comes from Ethereum. So Ethereum defines a smart contract as something which an autonomous agent can execute without human intervention. So you can have human intervention also, then the contract will not be smart. It will be a dumb contract, in the sense that somebody has to approve or reject it. Somebody has to see the event. It can be in pending for a day. And when they are looking at the contract, somebody with the public key having the roles and responsibility of authorizing the contracts can be manually clicking approve or deny. And when they are clicking approve or deny, the signature is getting fast with their public key, and the entire network is becoming aware of, yes, this contract is now working, or these transactions are now valid or not. So this is the definition of contract in the broadest sense.
And we have few more questions also. One is from Manish, how one should approach for blockchain career?
So if you're approaching for, yes, tell me, Monica.
Yeah, go ahead. And just quick a time check. We have 5 more minutes to wrap this up here.
quickly let me share. So how should one approach a blockchain career? So when you're working in software industry for a while and you find your interest is not in a particular role but at becoming very effective for something, or blockchain, the future I see for blockchain is that all these companies, like I told you, they need to have some sync with them. So either you get related to some service that is working on metrics, so Spunk is there, or some logging. There are a lot of companies with logging who are doing logging or some event management. Node.js is also very well known for events. So if you're learning Solidity or Truffle, uh, or if your career focus, right, it should begin from, I want to be effective. What do I want to be effective at? Do I want to be effective at how I'm processing events? Do I want to be effective at distributed systems? Do I want to be effective at legal systems? Like, do I know a lot about legal systems? Do I always read the terms and conditions? Am I introducing software and legal? Is that where I'm going with this? Because blockchain is also one way to provide exculpability for the clients, where they can say that this is the uh, money that we are taking for executing a particular contract, and it is well defined. So I can be charging people. I can do freelancing from this. So you can do freelancing on this career. Or another future I see is that as in when we are using more and more data, right? So now more and more people are reading about data. People are graduating from colleges with data analysis as their primary degree, and their data is coming corrupt. Their data is coming bad. So blockchain is the thing which I see in the future. It will have a scope for data integrity, where every data scientist or data analyst will expect that their data is verified in some blockchain, so that they don't have to deal with these edge cases. Because if you're not having a contract for your data, right, what will happen is eventually the data analyst or the data scientist will run into a interpretation problem, where they will not be able to interpret what the data means. And a lot of data engineers here will know what I mean by that. If you give a free text field, you'll be knowing what happens when you try to extract the data or load it, right? So these things are there. So possibilities are endless here. But freelancing is one of the things I can say. Creating your own company, entrepreneurship. I am also having a business. I can say, my interest started from blockchain only. Once I became aware of blockchain in 2017, I slowly started reading about business. Eventually, I am now working very successfully at a business. So, it is worth a lot of money to clients. They will be willing to pay if you're having the capability and the efficiency that I told you, right? The effectiveness at solving some problem. It will be worth it. Okay, let's take two more questions now. 2 minutes are there.
Okay, so the next question is from Jagajit. He's asking Hyperledger or Ethereum, which one is being adopted by business, at least by ThoughtWorks clients?
Okay, so ThoughtWorks clients primarily do not. So ThoughtWorks does not support or not support any technology. So Ethereum, there's something known as the Ethereum Alliance. Please check out the Ethereum Alliance. 100 plus companies have signed up for the Ethereum Alliance. Microsoft is one of their biggest supporters. Warren Buffett is having their own companies who is supporting Ethereum. A lot of things are there who are in the part of the Ethereum Alliance. Now these companies, if you're pitching them with Ethereum related things like Solidity or DApp, any of the DApp things like Truffle framework or so on and so forth, right? Those businesses will be very happy to have Ethereum. Hyperledger is also a fabric. So Hyperledger is also something which is being used by some clients. Again, it depends on how good your pitch is. It depends on your metric. Now, when I told you, right, if you measure a human by his ability to swim, he will look like a very poor swimmer. So this is exactly what I mean. It depends on which angle, which perspective you are judging Hyperledger or Ethereum from. So it depends for every use case on which business. You should know your client. You should know how to pitch to them, how to give the proposal. You should consider these factors.
And one more last question from Lennon. How ECDSA works and where it is applied in blockchain?
Okay, elliptic curve DSA cryptography method. It basically it will bounce around fractions on an elliptic curve. So elliptic curve is a basic curve, and it has some XY coordinates. And there are some rules for how to calculate this. You can read about how ECDA works. So the things will be bouncing around 1,000 times. So you're selecting a point, you're reflecting it. It hits another point, you're reflecting it again. And these reflections will happen. Each time the reflection happens, the point changes. And then you're taking some decimal accuracy. So the decimal accuracy is it will be completely random. So you're using that randomness to create your public key and private key. So ECDSA is being used to create your public key and private key, and which is also whenever you're creating your public and private key, right? It goes without saying that you need to have a signature creation mechanism. So ECDSA paper was created many decades ago, and in that Rivest and Shamir, these people, the creators of RSA, it is more compact than RSA. So for less bits, you're getting more security. At the same time, it is more vulnerable to quantum computer encryption. It is vulnerable to quantum tunneling. So this is, and it is applied in blockchain to create the public key, private key, and the signature. That is the use of ECDS. And to verify it, create the signature, verify the signature, and generate the keys, public and private. These are the three methods where it is being used. So yes, I hope that explains it.
Yeah, I think we are done with the QA questions. So thank you so much, Devashish, for your wonderful talk. I hope that's very informative, and thank you for sharing your knowledge. Thank you so much.
Thank you, Monica. Thank you so much. It's very nice to be here. And my social media details are here in case anybody wants to reach out to me.
Can you also share the GitHub link you have mentioned? Raghu has also asked in the question.
Okay. Yes, my GitHub is DEVSSH. There's something known as prototype-private-chain, which is in the same repository. There also, if you search for blockchain, you'll get a React.js front-end app and a back-end Java script app. And there's something known as so I'm not signed in, right? This is public. All these repositories are public. There's something known as yes. So you can say blockchain full node. What is a minor? Routing node? I don't think there's anything in routing node. But yeah, prototype private chain is there. You can check out Quorum. Cryptography libraries are there. And there is Kako SCS here. You can check this paper out. This is the link for the paper. You can check out what an RSA is and how to create control access and rules in that.
It also, this session is being live streamed in YouTube and it will be available in YouTube. Like you can go check there once again if you want.
Okay.
Thanks for the wonderful session, Devashish.
Okay. Thank you so much for having me. I'll just stop sharing.